In this session, we are going to learn RAG. It's an important and loaded concept as multiple things are attached. We are also going to look into vector databases. Why do we need vector databases and how different they are from conventional RDBMS? Specifically, we will explore Weaviate, that is one of the famous vector databases in the industry. We will also explore semantic search and then compare that with other search strategies and then see what are the recommended ways to implement search in RAG systems. It's going to be a little longer session. Stick with me. By the end of the session, I assure you, you will be very comfortable with RAG concepts and you will be able to do integration of RAG into your organization dataset. Let's start. What is RAG and why do we need that? So there are two important considerations. First one is LLMs, they are trained on certain data set and there is always a cutoff date when these systems go into production. The data which is available after that cutoff date, it is not updated regular basis into the LLM. So these LLMs have no idea about any data which is after the cutoff date. We have two options: either retrain these models from scratch to bring this data into the LLM, or um, provide this additional data on the fly as a part of the context. That is the second option. If we need to retrain the whole system, it's going to take a lot of resources and a lot of time and money. So better option is we can give the additional information as a part of the context on the fly. The second consideration is the private data part of any organization that is not part of the LLM. These LLMs has no access to any of the private information in your organization. That include in any format. It could be databases or S3 buckets or Active Directory or anything. So if you need to use LLM effectively, you need to provide additional data. There should be some sort of, you may say, in the layman form, we are going to give limited access to LLMs to the private data part of your organization. I copied this text from AWS. I really like this explanation that very well explained what RAG is. So one thing to remember is it's a process. RAG is a process. It's not a software. It's not a technology. It's a process. And the same thing could be implemented into multiple different ways. I will read the highlighted portion. So it says RAG extend the already powerful capabilities of LLMs to specific domains or an organization internal knowledge base, all without the need to retrain the model. It's a cost-effective approach to improving LLM output so it remains relevant, accurate, and useful in various contexts. All right, let's see the RAG workflow. So in conventional collaboration with LLMs, we have a prompt which is called user query. We directly send it to LLMs. LLM process the data and send it back the response. It's pretty straightforward. In case of RAG, we are going to change this flow. So instead of directly sending this prompt to LLM, first we are going to look into the local knowledge store for that organization and try to find relevant information related to this user prompt. And after that, we will create a newer version of the prompt. It will be original prompt plus the document or the data which we got from knowledge store, and we'll call it augmented prompt. So augmented prompt is prompt plus additional data from the knowledge store, and then send the augmented prompt to LLM. So in a way, LLM has additional data from the knowledge store, process, and then send the response back. Let's see one example. So if you see, we have a question, who works in HR? If you directly send this question to LLM, there are millions of companies and HR department. LLM has no idea what are we talking about. It may give us some very generic boilerplate kind of output. And in certain cases, it may also hallucinate and try to give some input, which is not very useful. On the other hand, the second option is we will say using employee records, which we are attaching here, who works in the HR, and that way we will get effective output from the LLM. Let's talk a little bit more about this knowledge store. This knowledge store is going to be a vector database, which is different than the regular databases like RDBMS or those kind of stuff. So in day-to-day basis, the databases which we use, they are for online transactional processing where the live transactions are going on. Those are structured and mostly normalized DB entities where they are designed for efficient and avoid the redundancy and that kind of stuff there. We are not going to use that. We will use unstructured data that will be stored into a binary format and into particular different directions. What do you call it? Multi-dimensional storage will be there, and it is going to store the content based on their meaning rather than the literal words or the keyword itself. So this is the next level. We will explore a little more into the next video, into the next slide. But overall, this knowledge storage is in the form of vector storage. What is vector database? So imagine a giant search engine for the meaning rather than the word. The focus here is the meaning of those words rather than the actual words. What does that mean is what is the meaning of that? Maybe we can call the same thing different words, but once exactly what it means, either way, when you try to search, it's either through different synonyms or some other alternate access to that. Either way, you will get the same stuff. So it says instead of storing the plain text, it stores vectors, numbers that represent the meaning. Um, these vectors allow the database to find similar ideas, even if the words are different. Let's see, look into two examples. If you see the word happy, if you store the word happy and try to search with word joyful, cheerful, delighted, all those things they have the similar ideas, and then vector database will be able to find that even though if you don't word the use happy. Um, if you compare this with the search, let's say for example in Oracle or using any SQL, you might use the wildcard search or those kind of stuff. There is no possible way you will be able to find out joyful with happy or cheerful with happy because that is based on the literal words and the based of the keyword rather than their meaning. Um, even if you even if you look into the search indexing engines, for example, if you see Apache Lucene or Solar or even Elasticsearch, none of them will be able to give these kind of stuff because all those search mechanisms they are based on the actual data rather than their meaning. So that's the extra benefit of the vector databases. And there is one very interesting example I saw on the internet. I'll like to bring that analogy. So if you see the word king minus man plus women equal to queen. So, so if you see king is for the title and it shows the gender, and this is again the gender and then again the title. So king because a man, but the same for if you try to remove minus man plus women, then it will be equivalent to queen. How this is stored behind the scene, let's look into next slide and that'll give us a better idea. We use SentenceTransformer. Transformer, what it does is it converts text into vectors. It creates tokens and then vector representation. They are translating the words into numbers. There are multiple models available. The model which we are going to use now, that is all Mini LM L6V2. It's a lightweight, and because I'm going to run this in my laptop, but it's pretty accurate there. If you see the example, let's say I love pizza, it will convert that into different tokens, and the output behind the scene, it will create a numeric representation. For example, this has 0.12, love is this number, pizza is this number. So that's how it is going to do the representation in the form of a vector. So the summary of this whole slide is this allows computers to compare the text based on the meaning, not the words. That's the important part here. Let's see one more further explanation for that. If you see the two words fairies and boards, both of them they represent same kind of classification, even though there might be minor differences. We will be feeding this into the classification into the sentence transformer, and then embedded model is going to create the numeric representation for that. For example, you see 0.12, 0.1, so both is same for fairies and boards. 0.13, 0.13, that's also same, and then minor differences. So it's major versus minor. So behind the scene, what it does is Let me go to the next slide. I'll show you how storage is done. So this is a multi-dimensional space. In this case, it's three-dimensional to show you, but in real life, it is going to be more and more dimensions will be there. And the concept is based on the meaning of the words. The words with somewhat similar meaning, they will be closer to each other, the close proximity. And the words who are very different or more different, they will be far away from them. For example, if we have these different words, if we need to represent this allocation, if we have boats and ships, since their meaning is somewhat same, they are in the same dimension and somewhat closer to them. While the word when the football came, football is far away and into a different dimension. Similarly, when the word banana, green apple, pear came, you see here the close proximity because they are belong to the same category of the apple. They are the same, so it's relatively closer as compared to football and that kind of stuff. So it really depends on their meaning, and that's how this representation work. Now, let me get back to the previous slide because I want to highlight this one more time. We use approximate nearest neighbor and search. So this technique focuses on finding the nearest neighbors to query the vector in high dimensional space with the trade-off between accuracy and computational efficiency there. All right, let's see one more diagram that will be relatively high level overflow how the drag framework work. The first thing is we have documents, metadata are there with different kind of documents. Could be Word document, Excels, images, audios, videos, anything what you have, we are going to provide to transformer and then do the embedding model, and then it will be converted into vector representation. You see here, this is vector. It's more array, or maybe if you go to developers and look into the learning center, there are different ways you can do the setup in the local machine. Instead of using the cloud version, I'm going to set up one locally rather than the cloud version. So I'll use the Docker. If you are already familiar with Docker and you have running in the local machine, that's well and good. Otherwise, I will just very quickly go through for the people who don't have it. So if you go to docker.com, go down here, and on the very first page, without creating any login, you will see a link for download Docker Desktop, and it will show you based on the environment, working environment you have. If you're using Apple MacBook or Windows, you need to choose the appropriate version, or the Linux. And similarly, within Apple, it's a Intel-based processor, or Apple made their own chip. You need to choose appropriately. And for Windows, if it's a laptop, it'll be AMD64. And if you are using a phone, small held devices, then it will be ARM64. So it really depends. You need to find out your own environment. In my case, I'm going to run it Windows laptop, so I downloaded Windows AMD64. Once you do the download, then follow the prompts and do the installation. I have already done the installation. I'm going to skip it. So once the installation is done, what we are going to do is go back here, and you will be able to see Docker desktop application will be installed in your start menu. You should be able to find out that. It's also running um, in the tray in the system menu. All right. Once this is done, installation is done, we are ready to go to the next step. That is, we are going to Docker Hub. And if you go down here, Docker Hub, on the main page, it's more like a repository of all the images. We are going to search for Weaviate right here. All right, you see the very first one with a large number of pulls are already there, 10 million plus. This is the artifact we are interested. If you go down, there is a lot of details here in the setup. You can read about it, but I'll just quickly go through. Uh, so if you see, go down here, the command is also given docker pull and the name of the artifact till here. And after the colon, that's the tag. Multiple tags are available. Even if you don't specify the tag, it is going to get the latest. So I'll just copy this line from here. All right, and then I'll go to terminal. Instead of using the standalone terminal, I generally use the PyCharm, and within the PyCharm there is a terminal. We'll use that one so we can see all these things under one place. Okay, I'll go here and open the terminal. First thing is, once you're done with the installation, we are going to validate whether the Docker is up and running or not. Say Docker dash dash version. So Docker 28.3, that is installed. That's good. Next thing is, we are going to download the image of Weaviate from the repository to the local machine. So this is the command. You can copy the whole thing, but I'll just go Docker till here. Here, copy that one and go back and paste it here. So it's saying using the default tag latest, because we did not mention the tag, it's going to download the image and it will show under the images when we go to the Docker desktop. Yep, it takes about 1 or 2 minutes. Let's wait for that. Right, once it is there, we can validate the image is downloaded or not. You just say Docker images, you run it, and you can see Weaviate latest and this tag ID, it's been downloaded. We are ready to run this, to convert this image into a running container. For that one, we are going to use Docker run command. So Docker run command, name of the image, and then we are going to give the port number and then run it that one. So before that one, I can show you visually also. When you downloaded the image, you see here the image is downloaded here. That looks good. And under container, there is nothing so far. We don't have any running container yet. I go back here, run it. Right, it is successful, and we can validate this in 2 ways. We can say Docker container ls, and it will show you the list of the running containers. And same way, we will go to the Docker desktop, and you see here images. This is the image, and under containers, it will show you the container is running, and these are the available ports here. Settings, and under settings, you go to the left side, you will see the API keys. By default, first time when you see the account, there will be no key. You need to create a new key. And the thing is, you need to put some balance. You need to use your credit card or something and put at least $5 so that you should be able to run these examples. Once you add the balance and the credit card and all the details, and then you will be able to create the key. Once you have the key, copy this key, and we are going to use this key inside the code. So we should be able to make the calls at runtime. All right. So what we do here is we'll go quickly, and in the code you need to create a file called environment.env, and then in file I have already put the OpenAPI key and pasted it over here. One good thing is if you go to the plugins, and very quickly we can see marketplace, and here you should be able to see env files right here. This plugin will be helpful for you to the integration where environment variables will be available at runtime, so you don't need to go and change the computer settings there. I just put it over here. At the end of the demo, I'm going to remove that part. Now let's get into the code. I have created one file. It's called employee record.json. If you see here, this is going to be my private repository. I have employee structure, employee ID, name, department, and their skill set, what projects they are working on, and what certification, and all the detail for each employee. I do have 6 employees with all the relevant detail. And this I'm going to do the ingestion into the Weaviate, and then we'll continue from there. Right. Next thing is we'll get into the code, and if you go here, it start with SentenceTransformer. We already look into it. This is going to the model as encoder. We will use it to convert the tokens into binary, into numeric representation there. And then read the OpenAPI key, and then we are doing connectivity with the Weaviate on the port, given port. And the next thing is we are going to create a schema inside the vector database. You need to give the name of the schema here, database employee, and then specify the property. This is a structure. So in the version 4, they expect you to give the name of the property and the data type. Name is a text, position is a text, skills, it's multiple values, so it's a text array. Projects could be multiple, so text array. All these kind of stuff you specify, and then you say collection.getEmployee. So this collection, once it's empty the first time, then we are going to put more data into it as we move forward. Right. This is very intuitive. Now let me get to the end. actually in the beginning of the project at the end. So what we do here is we do have 4 questions: who has the Python and machine learning skills, and find someone with sales experience or work in HR, that kind of stuff. And then we are going to use 2 different ways to run it. I'm going to run it in the for loop, and then we have 2 versions. One is without rag and one is with rag. Let's look into both of them. If you see without rag, here all we are saying is we are using GPT-4 or mini create the version, and all we are saying is whatever the direct question as is. We are not giving any additional context, and let's see what it grabbed here. So that's one way we say without rag, and now look into with rag. So the difference here is when you have a question, we are going to, before you send this prompt to GPT, we are going to ask this question: search employee, search it and find the relevant employee. There could be more than one matches through this search, but I put top key is equal to 1 to find only one, the exact match, and then get employee. So here's the punchline here. We have a model same, but if you see the role, we are providing additional context, which is the employee detail, whatever we found the most relevant from there. So in this way, this is augmented prompt. We will send this information and then see how it works. Right, so let me clear my console. Um, so we'll run both side by side, so you should be able to compare it. Let me comment all these questions, and for now post only one, so that at least we can start with some very basic comparison. So first question is, who has the Python and machine learning skills? Let me go here and let's try to run it. Before you run, we need to go to modify configurations, and under here you need to give the .env file to read the environment variables. Right, now we are running this application. Right, we got the answers. The first question: who has the Python and machine learning skills? So without RAG, without giving the additional information, GPT did not help at all. It says, I don't have access to your specific employee database, so I can't provide the information with who possesses Python and machine learning. So this is a very generic answer. It's not helpful, but if you see the with RAG, we are able to get the exact answer. It says Sarah Johnson has both Python and machine learning skills. The point to remember here is the question we posted here. These are not the exact words. So it's not like a keyword search into this .json file. It is based on the meaning of that because the exact words are not used over there. So that's the major difference between both of them. Similarly, we can go and I'll comment out this, and we should be able to run all the questions. So it should be, the concept is same. Sam, so see run. So by the time it's running, I will also show you different ways if you need to do some troubleshooting. Once Weaviate is configured, if you open the browser, by the time results are coming, we'll look into this. So the schema, once the schema is created, we can go and browse the Weaviate schema. For example, here, because when we created the initial properties, it created this object and all the properties are created. And if you give full URL with the class name, you can see exact data, which is also stored inside this schema. So for example, here, all the data along with the relevant details, everything is there. And it also show you at the end, total records are 6. So it's running on localhost 8080 v1 object. Give the object name class is equal to employee, and that's how you can easily troubleshoot this information there. Now let's get back to our questions. We posted 4 questions. Now we'll see side by side. Right, who was the Python and machine? Who has the Python and machine learning skills? This answer is completely is not helpful, and the second one is exact answer. That's good. Second one is, now find someone with sales experience. Look at this. Is the GPT answer, very long answer. No, not really helpful. But if you see the vidrag, its exact answer is right there. Who works in HR? This is all generic answer versus vidrag. Exact answer is there.